Good morning, ladies and gentlemen. Today we will talk about the first chapter of air navigation, that is the shape of the Earth. When we talk about the shape of the Earth is not a perfect sphere as you can see in this particular globe. The polar diameter is slightly lesser than that of the equatorial diameter. The polar diameter is 12,705.6 kilometers, and that of the equatorial diameter it is 12,748.6 kilometers. So if we take the difference between the equatorial diameter, that is 12,748.6 and the 12,705.6, and divide it by the equatorial diameter, that ratio is known as the compression ratio. Mathematically, if you see, it is nothing but the equatorial diameter minus the polar diameter upon the equatorial diameter, which is 1 upon 296. This particular value is known as the compression ratio. Why is it important to learn about the compression ratio? Is that depending upon the type of projection which you will be using in the map, okay, how flattened the Earth is depends upon this compression ratio. But as for all the practical purposes, that is for our navigational purposes, we can consider that the Earth is a perfect sphere like the one you see in this particular globe. So now let us define the direction, okay, the direction onto which the Earth is rotating. Okay, when we say that the Earth is rotating from west to the east, okay, the direction into which the Earth is rotating. That is why the very fact that the sun rises in the east is that if this is the sun and if this is the Earth rotating, the eastern side will come first. Okay, we will start seeing the sun from the eastern side. That is why we say that the sun rises in the east. Okay, and the direction opposite to the rotation of the Earth is known as the west. And if I stand, or if you stand facing towards the east, and the direction which is onto the left side of you is the north, and the direction which is right side onto you is known as the south direction, or the opposite to the north is the south direction. Okay, let us define some more lines onto the surface of the Earth. The first line which we are gonna talk about is known as the great circle. Great circle is nothing but the largest circle which can be drawn on the surface of the Earth. A great circle is a circle drawn on the surface of the sphere whose center and the radius are the same as that of the sphere, because they are the largest. Okay, so there will be no more circle which you can draw which is larger than a great circle. It divides the sphere into two equal halves. The smaller arc between the 2 points in a great circle represents the shortest distance. Like if you look at here in the diagram, okay, here we have got one point alpha, okay, another point which is point Bravo, which is on a great circle which is shown on a red line. Okay, the smaller arc, that is from here to here, the smaller arc, okay, between A to B, okay, this represents the shortest distance between this 2 point A and the B. And interestingly to know that all the radio navigational waves, okay, follow this particular path, that is the great circular path. Any other circle which we draw onto the surface of the Earth, like the one which is shown in the green here, okay, it is not exactly the biggest circle, okay, which radius is not as large as that of the sphere itself, and whose center is not the center of the sphere itself. Okay, this kind of a circle, okay, are known as the small circle. And when we talk about the equator is nothing. We keep hearing, or we have heard equator so many times. Okay, it is nothing but a great circle which is drawn perpendicular to the north-south axis. Okay, here this is the north and this is the south axis. If I draw a great circle which is perpendicular to the north-south axis, that particular line, okay, is known as the equator. So this equator divides the earth into two equal halves. That is, if you look at the diagram also, okay, the one which is onto the uppermost part, which is known as the northern hemisphere, the part which is the down below, which is in blue color, which I've shaded here, okay, this is the southern hemisphere. And some of the other lines which are important are the meridians. Okay, so why do we have to understand these meridians? The equator is that, okay, when I was starting my class, I said that when we fly from one place onto the earth to another place onto the earth. So how do we define, how do we describe this place onto the earth? Okay, so you can, the easiest way to describe, okay, for commonly is that, okay, New York. Okay, so when I say the New York is known to many people, so people will be able to go to the New York. But however, if I say that it is from Imphal, half of you might have not heard what is Imphal, where is Imphal. So you will not be able to go directly. You will require some time to find out where Imphal exactly is. So in order to have a standard description about the place, we need to describe in terms of some particular value. In order to define that particular value, we need to draw these lines and define those places in terms of these lines which are drawn onto the earth. One of the lines which are drawn in order to identify a place is a meridian. Okay, when we talk about the meridian are nothing but the semi-great circle, okay, passing through the north and the south poles. If I draw a semi-great circle, a great circle, okay, passing through north and the south pole, okay, one I can draw, okay, another one I can draw. Look at the, follow me on the diagram here on the screen, okay, third I can draw. So likewise I can draw infinite numbers of a great circle or the two diametrically opposite points onto the earth. Here the north pole and the south pole being the diametrically opposite poles, I can draw infinite number of great circles around this north pole and the south pole. And the semi-great circle which are passing through the north and the south pole, they are known as a meridian. Okay, and another half is known as the meridian. So here in this particular diagram, the one which is in the blue is a great circle. It is half of this great circle, that is the semi-great circle, which will be considered as a meridian, and the one which is opposite to that, which is drawn onto the red here, okay, which is known as the anti-meridian. A meridian and the anti-meridian thus will form a great circle, that we have just seen it. The meridian passing through the Greenwich, okay, there is a place in the Greenwich, okay, in the United Kingdom, okay, that particular meridian which passes through the Greenwich, it is used as a reference or a datum, okay, for meridian, for measuring this meridian. Okay, it also, we also can see that if I look at this, if I continue following one particular meridian, I will finally reach the north pole here, or if I go opposite to this direction, I will reach the south pole. Similarly, if I follow this particular meridian also, if I go upward towards the north, I will reach the north pole, and if I go southward, I will go the south pole. So it also represents, or it also indicates the north-south direction onto the surface of the earth. And all the meridians and its meridian will cut the equator at 90 degrees. Okay, if you look here, okay, this is a meridian, this is another meridian, this is another meridian, this is another meridian. All of them are cutting the equator at 90 degrees. And we also can, but whenever we fly, okay, we have to follow a particular direction. Okay, a line can be drawn if, okay, onto the surface of the earth, which cuts all the meridian at equal angle. That particular line which cuts all the meridian at equal angle is known as a Rhumb line. Why it is significant is, if we follow a Rhumb line, we can go from one place to another place maintaining a same direction. And similarly, there can be one such Rhumb line which can be drawn between two particular points on the surface of the earth. Or the equator, okay, it is always representing 090 direction, okay, it is east-west direction, so it is again a Rhumb line. If I talk about the meridians, these meridians always represent the north-south direction, the north-south direction, the north-south direction. So therefore the equator and the meridians are a example of a Rhumb line. So now, after having defined those meridians, we will again revisit one of the terminology which we have often heard, that is nothing but the longitude. When we talk about the longitude, okay, a longitude, okay, will be used to define a place. Okay, so a longitude of a place is the angle subtended by the smaller arc of the equator intercepted between the meridian passing through the place and the Greenwich meridian. So now if we consider in this particular diagram here, okay, the line which is drawn, the circle, okay, which is drawn here in the red color, it is the equator, okay, and if we choose a point, okay, here this is, let's say this is the point which we choose here, okay, the one which I'm encircling with the red, okay, this particular meridian is the meridian passing through that place. And we can also have a meridian drawn which passes through the Greenwich meridian, okay, and if I start measuring the distance, okay, if I started measuring from here, that is the Greenwich meridian, to the meridian passing through the point, okay, this smaller arc, this angle, this, okay, this arc which sustains an angle to the center of the earth, this particular angle is known as the longitude of a place. Okay, it is measured in degrees, minutes, seconds, and if you want to be very accurate, you can measure it in the decimals of the second. Okay, since, okay, if let us consider that this is a Greenwich meridian which passes to the United Kingdom, okay, this is the Greenwich meridian, and the anti-meridian is known as this is the anti-meridian. So if I start measuring from here, okay, onwards, till the time I reach, there can be 180 degrees. Similarly, there can be 180 degrees. So depending upon this place lies in the east of the Greenwich meridian or west of the Greenwich meridian, that particular longitude or that particular meridian which passes through that point will be annotated east or west, depending upon whether it lies east or west of the Greenwich meridian. The example is that east 0782830.5 seconds. Similarly, west 078 degrees 28 minutes 30.5 seconds. Okay. Now another terminology which we have heard so often, that the parallels of the latitude. Okay. So now equator, once we have drawn the equator, okay, that is the great circle which divides the earth into two equal halves and which is 90 degrees to the north-south axis. So any other line which I can draw parallel to the equator, okay, any other line, they will be all small circle. These circles or these lines which are drawn, which are parallel to the equator, okay, are known as the parallels of latitude. So since it is going from the east-west direction, it also defines the east-west direction. So now after having seen this parallels of latitude, okay, now coming back to my point once again, how to define the position on the earth. So now we use something known as a latitude, which you have heard. Latitude, when we say that latitude is nothing, latitude of a point is defined as the angle subtended by the smaller arc of the meridian passing through the point and the equator. Let's assume the point alpha, which is in the northern hemisphere. Okay, follow me on my pen. Okay, this is the point alpha here. I have drawn here. Okay, this is the meridian which passes through the point, that is point alpha. Okay, now I can draw an arc, take the smaller arc of this meridian which is from here to the equator. So this particular arc which starts at the equator and up to this particular point will subtend an angle theta, that is at the center of the earth or the center of the curvature, depending upon the definition. This particular theta or angle is known as the latitude of the point, and it is expressed in degrees, minutes and in seconds. And since this particular point A lies in the north of the equator, this particular latitude will be denoted or designated by the letter north, which indicates that the place is in the northern hemisphere. Similarly, if I choose a point which is south of the equator, the latitude of this point will be designated or annotated by south. Okay, similarly is an example. Okay, it is given as north 35 degrees 30 minutes and 36.36 seconds, and the south 35 degrees 30 minutes and 36.36 seconds. However, okay, in this point, so if I have defined the latitude and the longitude of the place, I can define the point onto the earth. Let us say that if I choose this particular point will have a particular latitude and a particular longitude. If I write the latitude and longitude, I will be able to go to this place directly. But as far as the standardization is concerned, okay, as far as the ICAO standard, okay, some of the people pronounce it as ECAO, okay, ICAO standard, the coordinate of a place on the earth, okay, is given in the World Geodetic Survey in 1994 format, which in short is also known as the WGS84 format. Okay, it is given in degrees and minutes and seconds, that is both latitude as well as the longitude. Now moving on further, I have talked about how to describe the point or the position onto the earth using latitude and longitude. Now if I need to go from a place onto the surface of the earth to another place on the surface of the earth, I need to know the distance, okay, between the 2 points. This distance can be measured, okay, in terms of nautical mile, which is usually used in the aviation. Otherwise we also will have come across something known as a kilometer. So when we talk about the nautical mile, which is nothing but the length, okay, kindly follow me on my mouse or a pointer, okay, the length of the arc of a meridian. Okay, as we see, the line which is in blue color is the meridian. Okay, the length of the arc of the meridian which sustains 1 minute of angle at the center of the curvature. Okay, if this particular angle is 1 minute, okay, at the center of the curvature, okay, the length of this particular arc we talk about, it is 1 nautical mile. Okay, so there are 90 degrees, okay, from the equator to the North Pole. So therefore 90 degrees have got 60 minutes. Okay, 1 degree has got 60 minutes. So therefore 90 into 60, 5,400 nautical miles. So therefore, if I have to say that the average distance from the equator to either poles, that is either to the North Pole or to the South Pole, will be equal to 5,400 nautical miles. And the 1 nautical mile, if we talk about in terms of meter, which is in aviation, it is considered as 1852 meters. The another system of measuring distance is kilometer, which is also similar to that of the nautical mile. However, it is in the gauge system. When we talk about the nautical mile, it was in the sexagesimal system. When we talk about the kilometer, it is in the gauge system. In a gauge system, in a right angle triangle, there are 100 degrees of grades, and this one grade can be divided into 100 minutes once again. So therefore, okay, now if I have to define the kilometer, the length of the arc of a meridian, the length of the arc of this particular meridian, which sustains 1 metric minute at the center of the curvature, 1 metric minute at the center of the curvature, is known as the kilometer. So now as we said that there is 100 grades in the one right angle, okay, and there are 100 minutes onto 1 grade. So therefore 100 into 100, which is 10,000 metric minutes will be there. So therefore 10,000 kilometers is the distance from the equator to either North Pole or the South Pole. So if we talk about the relationship between the nautical mile and the kilometers, as we come to know that 10,000 kilometers is the distance between the south equator to the either the poles, which is equal to 5,400 nautical miles. So therefore 1 kilometer will be equal to 0.54 or 0.54 nautical miles. Okay, thank you for watching this video. You can drop your questions in the comment box. And also, if you want me to cover any other topic, okay, you can also drop me onto the comment box. And if you like my video, kindly do press the like button, subscribe, and share it to your friends who want to study about the air navigation and any other subjects